In this episode of KubeFM, Alessandro Pomponio from IBM Research walks us through how his team went from a simple CLI prototype to a fully managed Kubernetes platform, all without a dedicated DevOps team. He explains how they built a GitOps-first architecture using Crossplane for infrastructure provisioning, Argo CD for application deployment, and Helm file to keep configuration consistent across environments. Alessandro shares how they manage multi-environment setups with minimal drift, using custom health checks and Git-based promotion flows to maintain reliability during rapid deployment cycles. He also talks about why they chose to build their own platform abstraction rather than adopt something like Backstage, and what trade-offs they've encountered along the way. For teams working with constrained ops resources, this episode offers real-world strategies for platform scaling, infrastructure as code reuse, and operator-friendly Kubernetes workflows. Special thanks to TestCube for sponsoring today's episode. Are flaky tests slowing your Kubernetes deployments? TestCube powers continuous cloud-native testing directly inside your Kubernetes clusters. Seamlessly integrate your existing testing tools, scale effortlessly, and release software faster and safer than ever. Stop chasing bugs in production. Start preventing them with TestCube. Check it out at testcube.io. Now, let's get into the episode. Alessandro, welcome to KubeFM. What 3 Kubernetes emerging tools are you keeping an eye on?
Well, I would say, first of all, I would say Kyverno, because it's a Kubernetes native policy engine that was made by the folks at Nirmata. It really speaks Kubernetes. It's done with YAML. It has a lot of documentation available and example policies. So check that out if you're looking for a Kubernetes policy engine. I would also say Argo CD. It's probably the most famous, along with Flux, tool for GitOps. They just released over a month ago, version 3. So check that out if you haven't done so already. And for third, I would say LLMD. It's a new tool that was a new project that was announced by Red Hat recently at Red Hat Summit. They want to make Kubernetes the de facto choice for serving LLMs at scale. So if you're into LLMs, check that out too.
Very good. So it sounds like you're quite active when it comes to checking out new tools. But for people who don't know you, Alessandro, can you just tell us a little bit more about what you do and where you work?
Yeah, well, I'm Alessandro Pomponio. I'm a research software engineer at IBM based in Dublin, and I'm working on next generation systems and cloud for science and AI.
And how did you get into cloud native?
Well, I always had a passion for cloud native, the idea of software that scales, but also managing infrastructure at scale. And so even when I was in university, I tried to find courses that were about cloud and distributed systems. And, with a bit of luck, I ended up where I am.
Congratulations on being lucky. In terms of, the active work that you do as a researcher to stay on top of all the different changes that are going on in the cloud native ecosystem, what resources work best for you? Blogs, podcasts, what works best for you?
I like having a feed of things, basically. So I usually check out LinkedIn. There are a ton of experts on LinkedIn that you can follow. There are pages for official projects and foundations like CNCF, Continuous Delivery Foundation, of course, Linux Foundation, what have you. So just engage with pages like that. Also, people and experts that you can find there, like Artem Laiko, one of the guests that you had on your podcast, is very knowledgeable about platform engineering. So I follow him, for example. There are other folks like Christian Hood that share tools from the Kubernetes ecosystem basically every week. So, just find what suits you best, right? What form you like best.
And if you could go back in time and share one piece of career advice with your younger self, what would it be?
Well, my career isn't that long, but for folks that are kind of, at their start of their own career, I would say basically, try to get some hands-on experience, because like early start of your career is basically imposter syndrome city, right? So if you have some kind of experience that you can use to back yourself up, it really helps.
Good advice. And now, as part of our monthly content discovery, we found an article that you wrote titled Taming the Wild West of Research Computing, How Policy Saved Us 1,000 Headaches. So we want to dive into this a little bit deeper. At IBM Research, you manage computing resources for some cutting edge science. Could you tell us about the environment you're supporting and the challenges you faced?
Of course. So my team works in a topic that's called accelerated discovery. Basically, there the idea is to speed up the scientific discovery process through new tools and technologies. Right? There are many talented people working on this from a variety of different backgrounds. You can have people that are more from an AI background, people from HPC, people from chemistry, mathematics, what more have you, right? And this is amazing for science, but for people that want to manage Kubernetes and OpenShift clusters, maybe they don't have the kind of background that we share, right? So sometimes they cause us headaches. For them, Kubernetes and OpenShift, it's just a way of getting resources for doing their science. And that's perfectly valid, right? Don't get me wrong. But for us, my team manages two large bare metal OpenShift clusters for the accelerated discovery topic. And, we definitely had issues in the past with people kind of misusing them or like not being very cloud native. So, for example, we saw people trying basically monopolizing GPU resources in our cluster by spawning interactive pods or launching like extremely large batch jobs that, due to the way the Kubernetes scheduler works, we're also scheduled on nodes that have GPUs compared to, nodes that don't have them. And they would just end up, jailing the resources because the node wouldn't have enough CPUs or RAM to basically schedule GPU-enabled workloads. So in the beginning, we kind of tried to handle every case by hand. Basically, when people would complain, we would log into the cluster, check out what's going on, try to tell them, okay, you can do this, you can do that. But basically, we quickly noticed that we couldn't really keep up with the demand, right? So we wanted to create some kind of automated way of handling things for us, basically, and some basically automation and enforcement of sets of rules that we as admins would define for our users.
Now, those resource contention issues sound familiar to many cluster administrators. What specific goals did you set to address those challenges?
Yeah. So basically, we had some processes that were too manual, right? So we realized that when starting to deal with a ton of requests. So basically, we wanted to address these things because we had a few admins that were doing things manually on the cluster, and we didn't have real visibility in between each other's actions, right? So, for example, if sometimes I would do things and I would forget to update a Helm chart or tell the others, they wouldn't know what I did, right? So we had a visibility issue. And trying to automate things also meant that basically we had GitOps just there waiting for us, right? We realized that we're missing a tool. So we wanted to adopt the GitOps approach in which we have, a single source of truth for our configuration of our cluster that gives everybody visibility, but also, gave traceability of our admin actions. And, if we make if we give a certain group a resource quota increase, we want to see when we gave it so that we can also take it back when we need for other groups to perform their actions, right? In addition to that, we wanted to handle these starvation of resources because especially near deadlines where people are really trying to get their experiments done, using often GPUs now that everything is using LLMs, but also, more other types of scientific computation that use GPUs. We want everybody to have their chance at using those types of resources. So we wanted to, for example, try to avoid people from creating these type of pods that they would then use as VMs by SSHing into them, because that's not really how cloud native works, right? You just want to create a job that runs its computation and then goes to its natural end, freeing resources for everybody else, right? And we also wanted to tackle the issue with large batch jobs being scheduled on GPU nodes because, we found that out like a while back, but we just we're asking people, oh, could you add this type of affinity rule to your job so that it doesn't get scheduled? But people are people and people forget, right? So this wasn't really scaling well. In the end, we also wanted to give some type of HPC-like semantics, even on Kubernetes, by providing queues to submit jobs for give this kind of HPC-like experience. Yeah.
And you mentioned adopting open source solutions rather than building custom tools. What technology stack did you end up choosing from the CNCF landscape?
Well, the CNCF landscape is really broad. Like there's a tool for everything now. Even just opening the page really lags your computer, and you can have a spaceship computer and it will still lag. There's so many tools, but that's also like the power of open source, right? So whenever you want to do something in a Kubernetes cluster or anything in cloud native, basically, I would say check that out before trying to do something on your own, because by using and choosing an open source tool that has been there for a while, you can basically stand on the shoulder of giants, right? There's proven experience, development, a ton of usage, and guides that can get you started pretty quick, actually. So that was one of our goals for this. So we started off with Argo CD to power our GitOps pipeline, let's say, our GitOps approach. And basically, along with Flux, it's probably the most common tool for GitOps. It's also, in our case, very easy to install because we're using OpenShift, and Red Hat packaged Argo CD as an operator on Operator Hub, so you can just one-click install it. It's also very easy to get started in general because it has a GUI that you can use, for example, just to track things a bit easier than just using command line, for example. For enforcing policies, we had a look at both Kyverno and Gatekeeper. Gatekeeper, we didn't end up going with that because it's using its own language called Rego for building policies. And, we are researchers too, and, managing the OpenShift clusters is not our primary job. So we wanted something that truly spoke Kubernetes, as I was saying before, and Kyverno has a ton of example policies, and it's using YAML, so it's very easy to get started with. It's also very powerful, but for people that need more control, for example, that have different requirements, always check out what tool is best for you. And there's no one size fit all. And for last, we chose Kueue for managing this kind of HPC-like job scheduling and job queuing. And because we saw that, well, other than being developed by one of the Kubernetes special interest groups, so that gives a good backing, it also has some kind of semantics to allow flexibility in terms of resources, and we really like that.
Now, and GitOps, you mentioned this now a couple of times, but we've noticed, through our work that it's becoming increasingly popular for configuration management. How did you implement this approach with Argo CD to manage your research projects?
Yeah, for sure. GitOps is becoming very much popular, and it's really interesting to see. I would say for people that are still on the fence about GitOps, I would highly encourage them to watch one of the talks that were given at GitOpsCon Europe just about a month ago by Ryan Atten from Red Hat. It was talking about some of the pros and cons of adopting GitOps, like, for example, a perceived, let's say, YAML fatigue, of a perceived loss of control that people might have when adopting GitOps. And but it was showing that even like Fortune 500 companies ended up choosing GitOps after some proof of concept systems, because they see a good return on investment. So again, if you're on the fence about GitOps, check it out. But in our specific case, we really wanted to reduce the amount of time that we had to manually intervene on our clusters for very simple actions like adding a person to a group, or changing some resource quotas, or provisioning a project, right? We also wanted to make sure that all the projects had a consistent base that was kept up to date with our latest version of our best practices, because before we were using some Helm charts, but they weren't really kept up to date. So we chose to go on with this GitOps approach, and we set up our single source of truth repository, and we started basically converting our Helm charts into some customized manifests. This was choice that was made out of personal preference. I'm not suggesting that everybody does it, but in my opinion, both for expert user and non-expert users, customize really helps understand what's going on. It doesn't have so much templating that makes it kind of hard to parse for some people. And I think it's even, again, for non-expert users, it's just better, right? So I also think that, with Customize, it really helps adopting a kind of Lego style approach to creating projects or manifests, right? You can create the base manifests with whatever you want. For example, in our example, we had the project configuration, we had a template group, we had resource quota, we had a simple customized manifest, and then you can build add-ons on top of it, right? So we created this kind of template project, but we also created some add-ons for additional permissions that we wouldn't want to include in for everybody, right? Because we want to try and keep permissions to a minimum. And one of the outcomes of this was that we were able to use Argo CD and application sets to really take out the maximum from this, because application sets allow you to create automatically an Argo application in using one of the generators. And one of the generators that we used was the Git directory generator, in which you can say, okay, look, there's a folder in our repository, and everything below that is a project or like an application of its own. So by creating a folder called user projects and a ton of folders below it, we could automatically provision an Argo application for each of the projects. And that made sure that we had each of the projects was inheriting from our base configuration, that we knew it was safe, it had all that we needed. And every time we want to update it, it also cascades down. Additionally, Argo has auto sync and self-healing mechanisms. So whenever we make changes, everything cascades down. And if a user tries to, I don't know, update its own group, which is something that we don't want to do because we want to keep it tracked, the Argo will reconcile the state, the actual state of the manifest to what we have in our GitOps repository, and the users will eventually understand that they need to go through a different process for doing their changes.
Alessandro, one of the key issues that you highlighted was GPU resources being monopolized. How did Kyverno policies help address this problem?
Yeah, so GPUs are definitely one of the most scarce resources in any kind of clusters. You can have tens or hundreds of nodes, but a limited set of GPUs. And especially when dealing with LLMs that take up often multiple GPUs to be loaded into memory, these become really scarce, right? So what we would observe in our case, it was that people were creating pods using commands like sleep infinity or tailing dev null to create a pod that was basically idle, and then using the SSH command to log into the pod and then use it as a VM, right? As an unofficial VM. And especially this behavior near conference deadlines, when everybody's trying to access GPUs, was causing us tons of problems, right? Everybody would reach out and ask us, why is my pod in a pending state? I need to run my stuff because my deadline is upcoming, right? And so when thinking about how to deal with this, we thought about trying to prevent people from launching these kind of idle pods by making sure people weren't running sleep infinity or these kind of commands. But then we just realized that was just a symptom of the problem, that was using these pods interactively. And Kyverno, as I was saying before, it has a very rich set of example policies. And you can just go on the website and find so many policies for every kind of use case. And one of the policies that was in the examples was about blocking pod executions, right? Pod execs. So we took that policy and made a few changes because we wanted to enforce some kind of exception mechanisms to the rule. And we also wanted cluster admins to be able to log into pods and see what was going on to help troubleshooting. But with a few minor changes, we were able to, reach out to the users, informing that we were going to introduce these kind of policies and deploy the policy, and then, give them help on how to transition from these kind of interactive pods to a more Kubernetes native approach. But at the same time, we had to introduce some monitoring tools, and also Kyverno helped with that, because they give you another example, policies that audits execs into pods. So with that, we were able to see what kind of namespaces we're using pod execs, what kind of users, and especially what the commands were. And with this type of monitoring, it really helped us, because in the beginning, we had a very strict policy where no pod execs were allowed other than from cluster admins. But we saw that this was way too strict, because people that were using commands like OCCP or OCRsync couldn't run them. So with a bit of troubleshooting and engaging with our users, we found out that we needed to add some exceptions. And for example, we ended up allowing pod execs on non-GPU enabled pods, because there's plenty of room in our clusters, right? So monitoring is very much important.
So beyond the exec restriction, what other policies did you implement to optimize GPU resource utilization?
Yeah, well, in addition to these kind of exec restrictions, we tried to set reasonable defaults for the number of GPUs that each namespace could use through resource quotas, to avoid cases where like one team would monopolize all the GPUs in the clusters. But again, even in this case, monitoring plays a very important role, because there are times where GPUs are in high demand, especially near deadlines, where maybe you want to be more strict. But at the same time, when there is low demand, we want people to be able to run their GPU workloads at full power, full steam. So with monitoring, you can also choose to increase the resource quota or decrease it based on the usage that people have, right? But we also try to tackle the issue of large batch jobs being scheduled on GPU nodes. As I was mentioning before, people were asked to use affinity rules to avoid GPU nodes on large batch jobs that weren't using GPUs, but people would just forget. And Kyverno has mutating policies that allow you to inspect, for example, the resource that's being submitted to the cluster, and then based on the resources that it's requiring. In our case, we were checking whether any of the containers were using GPUs. If that wasn't the case, we would just add the affinity rules, affinity annotations manually, automatically rather, using Kyverno. And we found this to be particularly effective because it can run completely transparently from the users, and it's not really disruptive, right? So users that would forget simply don't need to care, because we fix it for them. And we're admins, so we have this kind of we should help them, our user, right?
Fair sharing of resources is crucial in a multi-tenant environment. How did you leverage Kueue to provide equitable GPU access?
Yeah, well, our clusters evolve over time. So as I said, we have bare metal clusters, so we can have additional nodes being added, but also resource change over time. For example, we had T4s on the cluster in terms of GPUs. Then we had D100s, and then we added A100s and H100s, right? And we wanted to make sure that people could access GPUs in a fair way, but also thinking about two types of use cases. One, where users need a specific type of GPU because they have some requirements in terms of CUDA power or memory requirements, but also other situations in which a user just wants a GPU of any type, but they want a GPU, right? And they want to access it fast. By using Kueue, we were able to define resource flavors and cluster queues for each GPU type, so that we knew that people could access a specific type of GPU if required by their workload by submitting to that queue. But at the same time, we can take advantage of a mechanism provided by Kueue, where queues in the same cohort can borrow resources from each other. So in addition to defining queues for every single type of GPUs that we had, we define an additional cluster queue and queues for the local namespaces that had no resources attached to it, and they would just basically borrow resources from other queues. So if some people were using the, I don't know, H100 queue fully, if somebody was to submit to the generic GPU queue, it would see that all the H100s were taken and maybe route you to an A100, and that worked really well for us.
Many organizations struggle with the balance between flexibility for researchers and governance controls. What has been the impact of these implementations on your research environment?
Yeah, well, trying to strike a balance is definitely difficult. And in doing so depends on many factors, such as how many users you're dealing with, how much you trust them, what their usage pattern for resources are. So again, I feel like monitoring is very much important for that. In our experience, the changes that we discussed really benefited everybody, both admins and users. Users have been able to access their resources with far less problems, and have been able to avoid a long loop of asking us on Slack, oh, could you do this for me, could you do that. Now they can entirely skip that long feedback loop because we're busy people. They can just simply submit a PR to our GitOps repository with the changes that they need. Then we request our review. We then check to make sure that it's correct, that everything is done in the correct namespace and whatnot. And then we approve it, and Argo deploys it within seconds of us approving it, right? And basically, for us admins, also the administrative burden basically vanished, right? So we can focus more on our research and step in when actual issues arise. And we can also be sure that, by construction, every project is adhering to our best practices in terms of quota, policies, limits, and whatnot. So we don't have to worry about anything, basically, when people provision their new projects. So everybody wins.
That's great. The article that you wrote focuses primarily on technical solutions, but in many of our conversations when we're speaking about the use of Kubernetes, we often run into organizational challenges that these kinds of factors that can also be very important. How did you build support among leadership and ensure alignment with broader research computing strategy in order to get this done?
Well, hybrid cloud, Kubernetes, and OpenShift have been organizational priorities for IBM for a while. And one of the goals that both research and accelerated discovery has been to look, how Kubernetes native approaches can be adopted for hybrid workloads of HPC and AI. So enabling this meant we were aligned, so we didn't have to get too much support from our leadership. But in our specific case, the clusters had been there for a while, for a few years, and we wanted to explore how adopting new technologies could help provide a smoother experience for everybody involved with them, both users and admins. So in that sense, we had to make sure that all the admins were in favor of these changes, and we were able to monitor how these changes affected the users and the admins, right? But thankfully, measuring these changes was very easy because the number of requests that we get for support really dropped drastically. So that was very good. This type of governance, however, required some kind of upskilling in the admin team because not too many people were familiar with GitOps. We also had to have clear communication with our users, keeping them in the loop with everything we were doing, and making documentation available to them. Because this meant that users had to change their way of doing things. So we engaged them throughout our process, letting them know what kind of actions we were going to take, and then applying some policies, for example, on a subset of the users, and monitoring how well they were doing, if there were some clear problems before applying to everybody. And we gave them a lot of examples to make everything smoother, but it went really well. And also, attending conferences like GitOps-Con really helped us, or rather validated our approach, because we hear more and more people adopting the same approach. So that was very nice.
And for DevOps teams looking to implement similar governance in their Kubernetes environments, what key lessons or advice would you share?
Well, there isn't like one size fits all solution.
Oh, come on. I want a book. I want something I want something on a t-shirt.
Yeah, well, I would say we should probably start by making sure that you have a clear understanding of what you want to achieve out of this, right? Make sure you try to leverage as many open source tools as you can, because again, it's proven technology most of the time. So choose wisely, but also try to start from a smaller proof of concept that you can use to share with other stakeholders and get their support as well, right? And also, I one thing that I think is really important is that admins need to be very much empathetic with their users, because sometimes they just don't know better, right? You're probably the most knowledgeable people in your team, right? Try to make governance transparent as much as you can, right? For in our case, it was the addition of affinity rules, but make sure you tell your users what's happening so that they aren't too surprised, right? Adopt some monitoring mechanisms to see if things go wrong, because especially at the start, they probably will, to be fair. And be also ready to support some kind of exceptions, because there are some cases in which a policy cannot apply. So be ready to support these type of things, right? Of course, use automation as much as you can and invest in it early, because that will mean you get the most return on it. Set up some sane defaults and create add-ons with Customizer, your preferred tool like Helm, and GitOps all the way.
Very good. Alessandro, what's next for you?
Well, I would say we will try to get some more engagement with the communities, like KyvernoCon and more. And we're also thinking of open sourcing some tools that we've been working on for large scale experiments and benchmarking on Kubernetes. So stay tuned for that.
Excellent. And when you're not doing all this amazing work, what do you do in your free time?
Well, I like going on hikes, and we're actually I'm heading to the Dolomites in about a month. So some nature to go away from all this tech.
That sounds like a great plan. And if people want to get in touch with you, what's the best way to do that?
Probably LinkedIn. Send me a message. I'm always happy to hear from everybody. Just get in touch.
Very good. Definitely worked in my case. Alessandro, thank you much for sharing your time and your knowledge with us today. Look forward to speaking to you soon. Take care.
Bye-bye.